UTM now, as you have already known, UTM now is in red area of COVID-19, so everybody has to work from home. I'm working from home right now, so I don't have access to my magic whiteboard. So we're gonna have to improvise here, but I have pre-written my notes. I'm not sure how you going to like it, but we have to make do maybe for the next 2 weeks. I won't be able to go to office and have access to my whiteboard. But anyway, we are going to continue where we left off last time. So we already discussed about this transfer function. Transfer function is basically the ratio of the output over the input in terms of Laplace transformation, in terms of Laplace variable. If we are only interested in the input variable and output variable, all we need is just the transfer function. But we can also extract this transfer function from our block diagram. Our block diagram shows the relationship between all the variables, but we can simplify the block diagram, just get the relationship between the input and output, and therefore we are going to get our transfer function. So since our block diagram is not the same for everybody, but when we simplify our block diagram, we are going to get the same transfer function. After this, we are going to solve the system response using the transfer function that we get. Okay. So today we are going to learn about the simplification of block diagram into a single block so that we can get a single transfer function that only relates the input and output. So today we are going to learn simplification of block diagram. Okay, so there's some description there. What we are interested in is to reduce our block diagram into a single block. Then you can use this, what we call the block diagram algebra. Just look at the table here. So these two are equivalent. So here on the left-hand column is equivalent to on the right-hand column. If you have two summing junction, you can interchange the summing junction. See, when you either plus or you can add the first signal and then the second signal, or you can add the second signal and then you add the first signal. It will not make any difference. It is just equivalent. You can also split a single summing junction into two summing junctions. You can add together both signal, or you can add one at a time. So we say that this is equivalent. Most of the items in the table are self-explanatory. Okay, for example, here, if you have a block in series, then you can interchange them. This is just multiplication of two blocks, G1 and G2. You can replace with G2 and G1, and you can also just replace with a single block, which is just multiplication of G1 and G2. That is just self-explanatory. Okay, here also you can move the summing junction from behind the block to in front of the block, as long as you don't change the signal. So here C is A minus B multiplied by G. In this case, C is equal to A multiplied by G minus B multiplied by G. It produced the same signal. So we say that these two block diagrams are equivalent. You can replace the two block diagram without changing the original block diagram. Okay, you can also move the pickup point from behind in front of the block to behind of the block. You can see that C here is just A multiplied by G for both. Okay, you can move from behind the block to in front of the block by multiplying 1 over G. So here you get A multiplied by G multiplied by 1 over G, so you get back the original signal A. Everything here is just self-explanatory. Again, here you can move the summing junction from in front of the block to behind of the block. But the signal here, previously you don't multiply by G, and then you're going to multiply by G. Since you're going to multiply by G to make the original signal is not multiplied by G, so you multiply by 1 over G. So every time you can move a summing junction from in front of the block to behind of the block. If you have two parallel blocks, then of course this is just a summation of two blocks, just G1 plus G2. So what I want to explain further is the last element in the block. See, every time you see this feedback loop, you can replace with this equivalent block diagram. So I'm going to explain further here. So this is where I need my this is where I miss my magic whiteboard, but don't worry about it. I have pre-written my notes. Okay, so now if you have this, imagine that this is our whiteboard, and by the way, you don't have to copy copy notes today. Probably as long as I'll be working from home, I will post these notes to your e-learning after class. You don't need to make you don't have to copy any notes today. Everything will be posted on your e-learning. See, we have this feedback loop, and then we have this signal R and C. R is the input, C is the output, and then we have two more variables, Y and Z. You can simply write Y. Okay, you can simply write C is equal to G multiplied by Y, and the signal Z is C multiplied by H from the block diagram, and then Y is just R minus Z. So from the block diagram. So we have these three equations, and then we can eliminate. If we are interested in only R and C, from these three equations here, you can eliminate Y and Z. Okay, so 3 and 2. Okay, so you just put 3 in and 2 and then solve for C over R, which is output over the input. And this is the transfer function. So we say that you get G divided by 1 plus GH. And then we can say that these two block diagrams are equivalent. Every time you see this a feedback loop, you can replace that with G divided by 1 plus GH. G is the forward transfer function, H is the feedback transfer function. All right, so, do you have any question? So we are going to use this table, the table that we have discussed before. Here, this table, when we want to simplify our block diagram. So now let us simplify some block diagram to get the transfer function. Okay, let's take a look at this. Example 2. So to consider this translational mechanical system, of course, when we develop the block diagram, we get something like this. And then we want to simplify this block diagram into a single block using all the block diagram algebra. So how can we simplify this? It is not quite clear, but here you see this is a summing junction. You can split that summing junction into two. The takeoff point now you can take the same from the same signal. I'm going to redraw this. All right, so let's go to my notes. Okay, now see, I'm going to redraw this diagram. I'm going to split the summing junction into two, and then I'm going to split the takeoff point. Okay. So this is now splitting two summing junction and then just splitting the takeoff point. So this block diagram is equivalent with the original block diagram. I haven't done anything yet. I just split the summing junction and taking the takeoff point at two different points. And then if you see here the dotted line, you see this is just a feedback loop. So G is 1 over md square, H is equal to CD. So you can replace this with G divided by 1 plus GH. So G is 1 over md square, 1 plus GH, and then you can simplify that, and then you get 1 over md square. So you can replace 1 over md square plus CD. So you can replace the whole thing in the dotted red line with just a single block. Okay. So that is the idea of block diagram simplification. So that feedback loop now is being replaced by a single block. How do I get that? So because a feedback loop you can replace with G divided by 1 plus GH. In this case, G is 1 over md square, H is CD. After you have done that, then you see now this is another feedback loop. So this is the forward path G, is a more complex equation, and now H is just K. And then you just repeat the process. Okay, repeat the process, and then now your G is 1 over md square plus CD, your H is K, and then you can now simplify that into a single block. So this is what we call the transfer function that relates input to the output. You just replace the D operator with Laplace transformation S, Laplace variable S, and then you get your transfer function. Okay, that is the idea of block diagram simplification. Do you have any question? All right, so let us go to the next question. Next example. All right, so example 3. So produce the system transfer function using block diagram simplification method. So we have this block diagram. This is a block diagram that we have. Okay, how are we going to simplify this? Okay, so we have this. This is not exactly a feedback loop because you have summing junction there. This is also not exactly a feedback loop because you have input here, you have another output there, another output there. Okay, so you're going to need some practice to see what you need to do. So here, probably if we move this takeoff point from behind G2 to in front of G2, and then probably we're going to have something. So my idea here is to move this takeoff point from behind G2. I'm going to move that to the front of G2. So therefore, that signal must be divided by G2, because if we take from in front of G2, the signal has been multiplied by G2, and then you need to divide it again by G2. Okay, so let's go to my notes again. All right, so this is the original block diagram. I'm going to move this takeoff point from behind G2 to in front of G2. And then that signal must be divided by G2, because originally there's no multiplication by G2, but when we take in front of G2, that signal has been multiplied by G2, therefore you need to divide it by G2. After doing that, now you can recognize that this is a feedback loop. You can simply replace that with G2 divided by 1 plus G2H1. Okay. Everything in the red dotted line can be replaced with G2 divided by 1 plus G2H1. So that is the idea of block diagram simplification. See, my life is a lot simpler now because I don't have to draw everything on the whiteboard. We're going to save some time. I'm beginning to like this. Okay, so we're going to save some time here, so that I can do something else instead of drawing on the whiteboard. So now we can replace the one that is in a dotted line with G2 divided by 1 plus G2H1. Okay? But here now you have two block in series. Two block in series, you can just multiply them. You can multiply two block in series. Okay, so when you multiply that, so you have G1, G2 divided by 1 plus G2H1. Just multiply these two block in series. Now again, finally, you have this a feedback loop. Your forward path is this quotient here, and then your feedback path is H2 divided by G2. So the whole thing here can be replaced using the last element in the table, which is a feedback loop. For now, you can get the final block diagram. So this is now, after we have simplified into a single block, so this is the transfer function that relates only input to the output. So the transfer function is just the ratio of the input of the output over the input. Do you have any question now? If you have any question, you can type in the chat box. Oh, we can save a lot of time doing this. Maybe some of you can tell some jokes if you want. See, we have plenty of time today. Everything is pre-written. Too fast, doctor. Too fast. Okay, let's slow down. You can slow down. Okay, which one that you want me to re-explain? Which part that you cannot catch up? Too fast. Let us start from the beginning, okay? Let us start from the beginning. In the beginning, there were dinosaurs roaming on the face of the earth. Okay, forget about it. No, that's just a stupid joke. So let's go over this again. Okay, I'm going to go slowly now because we have plenty of time. We have plenty of time because it's already pre-drawn. So this is the original block diagram. This is the original block diagram. We want to simplify this into a single block. But of course, whatever you do, you cannot change the original block diagram, the representation of original block diagram. Otherwise, you're going to change the system. You are only allowed to perform something that does not change the original block diagram. So, but how are you going to do this? Of course, you cannot see in the beginning. For starters like you, probably you're going to get lost. You're gonna have to do some trial and error. Okay, but seeing here, there's some complicated signal going on here. There is no single item in the block that you can replace, because this is not a feedback loop, because you have a takeoff point in front of G2. You cannot simply just cut this takeoff point here. You're going to change the original block diagram. But in the table, you can move the takeoff point from behind of the block to the in front of the block. Let's go to our table here. We have the table. We can move. Let's go back to the table. There. See, you can move a takeoff point from behind the block to the front of the block. This is what we are going to do. If you move that to the front of the block, then you must multiply by 1 over G. 1 over G. When we move to the front of G2, and therefore we must multiply by 1 over G2 here. we are moving that takeoff point to the front of G2. Therefore, you need to multiply by 1 over G2 so that you get back the original signal. Okay, I hope that I explained that clearly now. Now to the second stage. After having done that, now you can see this is now just a simple negative feedback. See, you can replace the whole thing with G divided by 1 plus GH, which is the last element in the table. If you look back to the table, the last element in the table, this any feedback loop you can replace with G divided by 1 plus GH. See, this is plus and minus, here minus and plus. So normally we have negative feedback, and therefore here we have a plus sign. Okay? Right? Now you can replace that with G2 divided by 1 plus G2 over H1. This is the last element in the table. Now you have two series, two block in series. Let's go back to the table. Where is two block in series? Where is it? There. So two block in series, you can just multiply the two block together. Two block in series. So we can simply multiply G1 multiply with G2 divided by 1 plus G2H1, so you get that. Now again, finally, you have this simple feedback loop, even though your forward transfer function is a little bit complex, and the feedback transfer function is a ratio. You can still replace that with G divided by 1 plus GH, and then simplify. You just want a simple fraction. You want a numerator divided by denominator. You don't want too many fractions. You just want a denominator divided by a numerator divided by denominator. Do you have any question? Now, this may look simple, but sometimes a simplification of block diagram can be quite complicated. See, I have extract this. Okay, this is not in your notes. There's nothing there. There is the last example, I guess, from your notes. Okay, there's no more. I have extracted this from some tests back then. See if you can think what you're going to do. Oh, sorry. There. Okay. This is an additional example that I have come up with sometime this morning. So let's say you want to simplify this block diagram. This is quite complicated. This is, I bet. Okay, you want a simplification. You want just a single block diagram that relate R and C. I bet, I'm willing to bet money that most of you won't be able to solve this. You won't, but first time seeing this, you won't. How much, doctor? What do you mean how much? How much? What is how much? Oh, how much I want to bet money? No. The solution is already here. Of course, I cannot bet money. I already given you the solution here. See, imagine now seeing this for the first time in your test. Most of you won't be able to simplify this, but I have already, doctor. If we have the notes before the classes, we can follow your class while referring to the notes. Okay. Maybe next time. Maybe we'll do that. Okay, maybe you can have the notes. Then, if I give you the notes, then you don't have to come to class. Then how about that? How easy is that? How about I just put everything on e-learning, and then you can study my notes, right? I don't have to explain the notes anymore. No, forget about it. Okay. I'll try that. We won't understand after that. Okay, so now here, the idea is you're going to have to do some trial and error. You are going to have to do some trial and error. You need to think and crack your head. How are you going to simplify this? So my idea is to move this summing junction from in front of the block to behind of the block. See, I'm going to move the summing junction from in front of the block to behind of the block. If you look at the signal, let's say this is B, this is A. The signal coming here is A multiplied by G2 plus B. So this signal here. So you don't want to change that. You want that to remain A plus G2 even after you have moved the summing junction behind of the block. Okay, let us retrace here. So here this is B divided by G2. So this is A. Signal here is A plus B divided by G2. And then once you multiply by G2, you get A multiplied by G2 plus B. So you see this is equivalent. A multiplied by G2 plus B. So by moving the summing junction behind the block, the signal here remains A multiplied by G2 plus B. See, there's nothing new here. We don't change the original block diagram by moving the summing junction from behind, in front of the block to behind of the block. Okay, you can go back to your table. There's a table. See, you can move this summing junction from in front of the block to behind of the block. So we are going to use that. Okay, so we are moving that summing junction from in front of the block to behind of the block like that. Okay, now you see here, this is two summing junction. You can interchange two summing junction. Again, let's go to the table here. There. No, not that one. So this one. So you can interchange two summing junction. You can do that. Okay, now I'm going to interchange these two summing junction. Okay. Now, okay. When we get to here, I'm not going to bet money anymore. This is now it's easy. This is easy. So this is now just two blocks in parallel. It is two blocks in parallel. Let's go back to the table. Two blocks in parallel. Where's two blocks in parallel? There. When you have two blocks in parallel, it is just G1 plus G2 here. So in our diagram here, so this is just two blocks in parallel. One of them is 1 over G, one of them is 1. So you just add them together, 1 plus 1 over G2. And this is all just one long block in series. So you just multiply them and then you get the final simplified block diagram. Just multiply everything and then you can get now the single block. You need to put everything in numerator divided by the denominator. Okay, so that's the end of my notes. Do you have any question? All right, next time I will try to put my notes. The problem is I have just finished my note. Doctor, how to know? Of course you don't know your answer is correct or not. What do you mean how to know your answer is correct or not? Of course it's going to be correct. It is like doing algebra. Let's say x is 2x plus y equal 3, x plus 3 equal some negative 5. When you solve it, of course you're going to know it's going to be correct. You just need to have some confidence in yourself. Of course, in your test, you won't know whether it's correct or not. But hopefully that we have confidence enough in ourselves that this is correct. I might be wrong. You might find some mistake in my notes. That is normal to do some mistake. All right, so that's the end of my notes for the first hour of this class. If you don't have any question, I think we're going to take a break. We're going to take an early break. So come back here at 4:45 for our next class. Okay, come back here at 4:45. You don't have to copy any notes. I'll put this on your e-learning. All right, so come back here at 4:45. By the end of next class, I will put our notes, my notes, to your e-learning.